Hello and welcome to Polarify Consulting. I'm Jazz, and today we're diving into the fascinating world of haptic technology. Whether you're a tech enthusiast, a professional in the field, or just curious about the latest innovations, you're in the right place. Haptic technology, often referred to as haptics, is revolutionizing the way we interact with digital and virtual environments. Imagine being able to feel the texture of a virtual object, sense the vibrations of a smartphone, or experience the resistance of a game controller, all through the power of touch.
Hi, I'm Francesca. So Jazz, can you explain what haptic technology is?
Sure, haptic technology, or haptics, allows you to experience the sense of touch in a digital or virtual environment. It creates tactile sensations like vibrations, motions, or forces when you interact with electronic devices or virtual objects.
How does it work in everyday devices?
For example, the vibration you feel when typing on a smartphone touchscreen is a basic form of haptic feedback. It lets you know your touch was registered. In video games, haptic controllers can vibrate or provide resistance to mimic the feeling of firing a gun or hitting something with a weapon.
What about in virtual reality?
In VR, haptic gloves or suits use motors and actuators to create the illusion of touching virtual objects by applying forces to your skin. This makes digital interactions more intuitive, immersive, and realistic by engaging your sense of touch, in addition to sight and sound.
And how is AI used in haptic technology?
AI enhances haptic feedback experiences in several ways. For instance, generative models like GANs and autoencoders generate realistic haptic sensations by learning from large datasets of real-world tactile data. Machine learning enables systems to adapt and personalize feedback based on individual user interactions and preferences.
Hey, I came across some terms like GANs and autoencoders. Can you break these down for me in layman terms?
Of course. Let's start with GANs, which stands for Generative Adversarial Networks. Imagine GANs as a game between two players. One is a generator and the other is a discriminator. The generator creates fake data, like images or tactile sensations, while the discriminator tries to figure out if the data is real or fake. Over time, both get better at their jobs, and the generator produces data that looks very realistic.
So, it's like a competition between two AI models?
Exactly. The generator wants to fool the discriminator, and the discriminator wants to catch the generator's fakes. This back and forth helps the generator create highly realistic data, which in the case of haptics, means more lifelike touch sensations.
Got it. What about autoencoders?
Autoencoders are another type of AI model. Think of them as a way to compress and then reconstruct data. They have two parts, an encoder and a decoder. The encoder takes the input data and compresses it into a smaller, simpler form. The decoder then takes this compressed data and tries to reconstruct the original input.
So, it's like zipping and unzipping a file?
Exactly. In the context of haptics, autoencoders can learn the essential features of touch sensations and then recreate them. This helps in generating realistic tactile feedback by focusing on the most important aspects of the sensation.
And how does machine learning fit into all of this?
Machine learning is like teaching a computer to learn from experience. In haptics, machine learning algorithms analyze how different users interact with touch feedback. Over time, the system learns each user's preferences and adapts the feedback to make it more personalized and effective.
So, the system gets better at giving me the kind of touch feedback I prefer?
Exactly. By learning from your interactions, the system can provide more intuitive and satisfying touch experiences. It's all about making the digital world feel more real and responsive to each individual user.
Can AI predict user actions in real time?
Yes, AI models can anticipate user actions and environmental changes to provide predictive haptic feedback in real time. This allows for smoother, more natural haptic experiences without delays, which is critical for immersive applications like VR and teleoperation.
How does AI help in combining different types of haptic feedback?
AI helps combine multiple modes of haptic feedback like force, vibration, and texture into unified, coherent experiences by understanding how the different feedback channels relate. This enhances realism compared to separate unimodal feedback.
What about object recognition?
AI algorithms enable real-time object recognition and environment understanding. This contextual information allows haptic systems to dynamically render appropriate tactile feedback when interacting with different virtual or remote objects.
So, what's the overall goal of these advancements?
The goal is to make haptic technology more realistic, precise, and integrated into various applications from entertainment to healthcare, ultimately improving user experiences and functionality.
I think we covered all we needed to talk about. Right, Jazz?
We did, Francesca. Thanks for watching.